This is the worked answer to the Mechanics Unit 9 test question 1. In this question we are told that a body is moving in a straight line and it's given by this equation where the velocity is changing relative to time. So v equals minus 1/3 of 2t squared minus 9t minus 18. We're asked to find three things in this. We're asked to find the initial velocity of the body, we're asked to find the value of the t when the body is instantaneously at rest, and you're asked to find the greatest speed of the body within the first 7 seconds of motion. So what I'm going to do is, looking at this, I can see that it's a negative quadratic, so I'm just going to draw a sketch of my negative quadratic. Where the x-axis is time, or t, and the y-axis is velocity. And the question's asked for three things. In part A, we was asked for the initial velocity. So we was asked for when t equals 0. So that point there is the answer to A. In part B, you're asked when the body's instantaneously at rest. So you're asked for this point here. In fact, when you solve that, you'll get 2 points. You'll get this imaginary negative time point over here as well. And then in the final part of the question, you're asked to find the greatest speed. So you're asked to find this coordinate here. So if you understand the graph, you'll clearly be able just to use calculus, or alternatively we can use what we've learned in mechanics. So in part A, to get the initial speed, all we're going to do is we're going to let t equal 0, because at the start t is equal to 0, so that means v, which is minus 1/3 of 2 0 squared minus 9 lots of 0 minus 18. You can type this in a calculator, or you can say it's minus 1/3 times minus 18, which is 6. So that tells me the initial speed is 6 meters per second. In part B, we're asked to find this coordinate here. So we're asked to find when velocity, or when the body's at rest. So we're going to say 0 equals minus 1/3 of 2t squared minus 9t minus 18. So by factorising this, I can get minus 1/3 2t plus 3 t minus 6. And solving this, I'm going to get t equals minus 3 over 2 and t equals 6. This is just a coincidence that the root happens to be the same as the y-intercept. That won't always be the case. Clearly we'd want the positive time, so t is equal to 6. In part C, we're asked to find the maximum speed, the greatest speed of v. So we can see graphically that that means the gradient is 0, or in terms of mechanics that means acceleration is in terms of 0. So if I differentiate velocity, I'll get the acceleration. So dv dt will give me acceleration. So I'm going to differentiate this function. So I'm going to ignore the constant, and this is going to give me 4t minus 9. And I want to know when will this equal 0. So minus 1/3 4t minus 9 equals 0. And this will happen when t equals 9 over 4. When you substitute 9 over 4 into the function of v, so instead of substituting 0, put 9 over 4 in here, you get v equals 75 over 8. So what we have just done is worked out the greatest speed. We have also found this coordinate, so that coordinate is 9 over 4, 75 over 8. Not that I'm recommending it, you could also have taken advantage of the fact that it's a quadratic and has a line of symmetry, the line of symmetry being here. So we could have got the value of t by adding these two values together. So 6 plus 3 over 2, plus minus 3 over 2 divided by 2, that also would give us 9 over 4. But clearly this is the method that is expected, and this method will allow us to work with cubics and other polynomials that we may be given.